Welcome everyone to this webinar about how to automate transmission grid inspection using Sterblue. Happy to welcome you on this webinar. So today, the panelists, we are 3 people. So myself, Vincent, co-founder and chief technical officer of Sterblue. I'm replacing Geoffrey, our CEO, who had a last-minute important appointment. Samir, which is our senior account executive, and Nicolas, our chief product officer and co-founder. So yeah, feel free to ask questions in the Q&A section in Zoom. We will be able to answer them anytime during the presentation. So the agenda for today. So we'll start with a glimpse of Sterblue, the company, our market, who we are, where we are based. Second, we'll talk a little bit about market evolution and trends that are going on in the transmission grid inspection at the moment. Then Samir will talk about multiple use cases that our platform address. And finally, Nicolas will explain concretely a few business cases and perform a live demo of Sterblue product. And finally, we will have around half an hour for Q&A, so feel free to ask any question. Okay, so let's start with a glimpse of Sterblue. So Sterblue is a company founded in 2016 by 3 co-founders, Nicolas, Geoffrey, and myself. We have offices in France, Portugal, and the US. Our mission is simple. We build the integrated platform for infrastructure inspection. And in particular, we are focused on the energy sector. So we focus on automating inspection of wind turbine, transmission, distribution grid, cooling towers, and similar assets in the energy sector. We're a startup. We rose funding from top investors, including Y Combinator, the largest startup accelerator in the Silicon Valley, EDP Venture, Future Energy Venture, the Wesley Group, and C Ventures, which are all investment funds focused on the domain of energy and clean technologies. Yep. We have more than 40 customers in 19 different countries. Our customers are large utilities or their subcontractors, O&M subcontractors. We are present on all continents, from Australia to North America, Europe, Africa, Asia, and South America. We inspected today more than 5,000 kilometers of power lines on pretty much all those continents with different means of inspection. So Sterblue product in one small timeline. So we help you gather clean data about the grid. There's a mobile app that can connect to drones or that can capture photos by itself. This mobile app is connected to the Sterblue Cloud platform, which means that when you capture data, you can then manage it on our cloud platform, analyze it using artificial intelligence or human in the loop, and monitor your asset health using dashboards on the cloud platform. You can also get data coming from various data sources. It doesn't have to be drones or directly the iPad. It can also be satellite imagery, helicopter-based imagery, or any imagery that you have on your side. So that's it about Sterblue. If you have some more questions, we can address them later on. So about the market evolution and tech trends, so a few insights. So for inspection of transmission grids, we've noticed when we started around 2015 that drones were in their beginnings. People were learning about drones. They started to perform experiments to try to inspect some small scale structure. Basically, the drone was just used as an eye that can go a bit higher in the sky, cheaply, more cheaply than using a crane on an helicopter. Then, as people started scaling up this approach, we noticed that people started struggling with data, overflow of data from various sources. how to cross the data coming from drones and the data from your GIS, from your geographical information system, how to cross that with information gathered from the ground, from helicopters, and so on. So people started being a bit overwhelmed with this data, and we realized that that's when we realized that the main value proposition in this market is not that much about data capture. It's more, what do you do of this data afterwards? And that was a pain point of our customers, and that's why we focus on that. And now it's coming the time of digitized workflow and added value for the market by actually organizing this data, like having clean data that is organized, that we can apply artificial intelligence on. This is where the value is. This includes data, as you see, from drones, satellites, and so on. So the first trend that's coming about that is artificial intelligence. As you see on Sterblue platform, you can have images like this where the AI will find all corrosion on the tower. So just on one photo, you can have a few hundred detection of corrosion or of equipment. And you can have 100 different pictures per tower. So you end up with a massive load of data, and then you need to do something about it, apply business domain rules to know when to raise a red flag about your infrastructure or not. Second trend is digitization and modularity. So basically, as Samir will tell you a bit later, each one of us has a different use case. So one platform cannot address this if it's not flexible and modular. So we made Sterblue modular. Our platform is getting more and more modular to address each of your use case precisely and efficiently. The next one is ecosystem openness. I mean, there's no silver bullet. Sterblue is not a silver bullet, but by being open to the ecosystem, using open standards and integrating with more than 2,000 different other platforms, it allows Sterblue to integrate seamlessly in your workflow. Just an example, if we detect problems on your infrastructure, we can send you an SMS through Zapier. When we find equipment on your grid, it can be uploaded directly to ArcGIS and so on. And finally, the last one is digital twin and asset modeling. Sterblue keeps a really precise representation of your assets internally. And this allows to track and organize your data efficiently. Okay, so I will now let Samir speak about the multiple use case that our platform can address.
Yeah, thanks, Vincent. I will be sharing my screen then. One second. Yes. So Sterblue, as mentioned by Vincent, is the unique actually data platform for the inspection of your assets. So today, to inspect your assets, you may have several sources of data, so helicopters or drones flying automatically using the Sterblue interface. But you may also have actually several inspection goals. You may need to assess corrosion, or you may need to detect the bended bars on your infrastructure. You may need maybe to see in details your insulators, and you will have also several types of users. So the teams who are doing the inspection, the teams who are managing the maintenance, maybe the management layer who needs to have an overview of an asset, of the health of the asset very quickly. So all of these parameters will create multiple use cases. So the goal of the Sterblue data platform is to address all these use cases through configuration abilities and through through handling several sources of data. So maybe here I can mention some use cases that we have explored with our clients, for which we provided solutions so far. So the first one being helicopter inspections. So today we have a solution to collect automatically data using drones, but we realized through working with some of our clients who have assets spread out in large territories and maybe very remote places, the drones may be not the best way to collect data. So for this kind of clients, we use the helicopter pictures, which we process on the very same data platform, which is the Sterblue data platform, and we provide inspection results. Another interesting case maybe is vegetation management. So vegetation management usually is assessed using LiDAR data collection, which can be slow and expensive or both. So at Sterblue, we use satellite pictures, which is quite new in the market, to measure the distance between the lines and the vegetation that can generate encroachment risks. And we provide the results on the very same platform, which is the Sterblue platform. And actually, the outputs are used by our clients to provide inputs for the tree cutting contractors. Maybe another use case I can talk about here is the emergency inspections. So several of our clients may face issues covering large distances of lines while inspecting after a storm or any other extreme weather events. So this is actually, we can have examples of this in Australia after, actually it's one of the reasons that is suspected to have triggered fires, or the same issue in California 2 years back. So in order to avoid this kind of issues, so after an extreme weather event, the drones today with the Sterblue app are able to cover large distances of infrastructure, and all the data collected can be managed on the Sterblue platform and allow the client to have a very fast reaction to fix any issues that are generating a threat. So we will actually be seeing some other use cases demonstrated by Nicholas at the end of this presentation. So yeah, first of all, maybe we may ask you a question, just maybe to adapt maybe the presentation we'll be doing afterwards and to orientate it towards your specific concerns. So the question will be, which of the use cases are the most important for you? Is it detailed inspection, inventory management, live emergency inspections, vegetation management, or creating a digital twin and augmented GIS? So you have a pop-up on your screen where you can actually select the answers. You can multi-select them and have multiple answers if you are willing to. So yes.
I think I can close the poll.
Yeah, maybe let's wait maybe 10 additional seconds, then we can close it.
I already closed it.
You already closed it. Actually, I don't see the results, Teresa.
You don't see, okay.
Yeah.
So okay, I will share it. I think now you can see it.
Yeah, perfect.
Yeah.
I see them now. So yeah, so actually I wanted to comment on the results, but as I wasn't seeing them, it was difficult. So yeah, so now actually I have the results. So the first rank is for detailed inspection. Second one will be live emergency inspection, and then we have vegetation management. So yeah, so this answers is quite consistent with what Nicholas will be showing as an example at the end of this presentation. We will be addressing the topic of detailed inspections with our clients with two of our clients, one in Australia and one in the United States of America. So yeah. Let's move to the next slide. So, so in this webinar, as I said before, the topics we will be focusing on are the detailed inspections. So the detailed inspections is performing a full assessment of tower integrity using drones. So drones, as I mentioned, is the way that we favor for several use cases to collect data in a standard and the proper manner. But there may be some other ways to collect data that can also be handled by the Sterblue platform. So the second use case is inventory management. So having an inspection covering all the assets allows you to see all the defects that are present on your grid to plan your maintenance accordingly. But another information that may be useful in this case is getting to know what kind of equipment is present on the grid. So you can actually plan the budget to replace it, and also plan more accurately the maintenance. So for that, the artificial intelligence which is deployed by Sterblue can detect the defects and also the equipment on your grid and provide you better knowledge of your infrastructures. So the last topic will be vegetation management. So as mentioned before, here the goal, without needing to deploy any operations on the field, to acquire satellite pictures and calculate the distance between the vegetation that may be causing risks on the infrastructure to the lines themselves. And then we provide you the results on the same platform, and we may be able to deploy additional drone inspections to provide you even more information about the vegetation which is causing a threat on the grid. So yeah, so the Sterblue platform today has a standard workflow for every mentioned use case. But today we are very aware of the fact that every company we start working with has internal policies to manage the inspections, to manage the maintenance, or to manage the vegetation. So the goal here is to have a solution using all the Sterblue models, which is adapted to your specific use case. So the specific use case of any utility company we start working with. So for that, the way we proceed is we start with analyzing the existing process of any new prospect or client we work with. Once we have defined this process, we identify the pain points and define a target process that we would like to deploy using the Sterblue software. So this will be the step one of the relationship with our utility clients. And at the end of it, we have actually a target process we would like to implement with the Sterblue platform. Then we deploy this target process with the Sterblue platform on a limited volume of assets. So this pilot project will allow us to see in reality how this process works, and also to define the main value drivers that actually to define the main value drivers that will allow us to adjust this process and deploy it on the larger scale. Once we have this feedback from the field, we build the business case and we anticipate what will be the benefits of implementing such a solution on a larger scale. And we have the target final workflow that we scale on an industrial level, while deploying a change management plan, allowing you to also reorganize your teams, maybe run some trainings in parallel to get the internal teams familiar with the use of drones, the goals behind using AI, and how to use the new solution in general. So the value drivers that we have seen so far, which the importance of every value driver can be variable depending on the clients we are working with, but this is actually a synthesis of what we have seen so far. So the first value driver is that several of our clients have several sources of data that combined provide this the full information about asset integrity. So the goal behind having one central data platform such as Sterblue is to store all this information in one standard model. So having all this information in one standard model allows you to extract insights, to aggregate the data on the line level, on the region level, and then to try to take strategic decisions in order to implement maintenance plans at a lower cost and at a better efficiency. So then the other value driver is that the Sterblue platform today can manage high resolution pictures from several sources. Some of our clients used to have only pictures taken from the ground. And so these pictures are usually don't provide full visibility on the equipment present on the towers. For instance, we cannot see the insulators from the top of the tower or from the side. So the Sterblue platform allows you to manage this kind of high resolution pictures and see the insulators like if you were flying around the tower by yourself. Then the third value driver is that today there is an AI, so it's neural networks that we have trained to detect automatically on the pictures we collect the defects and the equipment present on the grid. So this AI doesn't replace the expert that have actually an additional level of expertise and can produce conclusions, take decisions of what maintenance actions need to be undertaken. But for now, we have measured that that our clients save 30% of expertise time thanks to this AI that pre-labels all the defects on pictures for them. The fourth value driver will be the output. So once you have the Sterblue platform, you expect from it to have various types of outputs. For example, if you have a problem, a specific contractor who is in charge of painting the towers which are in metals, you obviously will need to provide him maybe a PDF report with the lists of all of the corrosions present on the towers. So for that, you can output from the Sterblue platform this filtered corrosion report in a PDF format. Then you may have actually some other systems that are involved in this inspection and maintenance process. For instance, like SAP, where you may be creating all the maintenance tasks and following the budget of these maintenance tasks on the same system. So for that, today, Sterblue has an API and can also manage flat file exchange through CSV files. And using this API or this flat file exchange, we can connect with pretty much any type of system present in your IT landscape. The fifth value driver will be that the Sterblue platform today can manage several user profiles. So several teams in one company and even across companies can be all gathered around the same tool to manage the inspection process. So the contractors who are in charge of the inspection can feed the platform online by the pictures they collect. The utility company can actually see all the results of the inspection, so the defects present on the grid and all the data collected. And the maintenance contractors, for instance, can see the reports and take action to correct the defects that has been detected during the inspection. The last file of the value driver we start to see in some cases is that some of our clients, so utility companies usually, are having contractors who provide them inspection reports, but they don't have the ownership of the inspection data which is collected by their contractors. So here at some point, there is a data ownership issue. Data today is strategic. Everybody wants to have the ownership of the data to implement, for instance, predictive maintenance and to have a strategic advantage on the market. So using a platform like Sterblue allows you, so our utility clients, to follow up all the data flow since its collection till the last step, which is actually producing the insights or sharing this data with other systems using the API or using a flat file exchange. So how you can start working with us? So today the Sterblue is a platform providing tools to collect the data, to process it, detect automatically the defects, and provide the insights and define the reports. So you may use this platform as a SaaS solution, so software as a service. So we charge you per inspected asset, and we provide you access and train you to use the platform, and you may use it autonomously. On the scope that which is relevant for you. Then also we can use the Sterblue platform by ourselves to provide you the full scope service. For instance, if you need to assess the corrosion on your towers, we may send our pilots to use the Sterblue software to fly around the towers, and then use the AI to detect for levels of corrosion, and at the end of it provide a fully comprehensive corrosion report that we provide you at the end of the process. Then there are hybrid models that can mix these both options. For example, if you would like your experts to be using the platform to assess corrosion by themselves, taking again the corrosion example, but you don't want to implement an internal drone capacity to fly around the towers, we can just fly around the towers, provide you all the pictures, run the AI, and let you produce the reports and take care of all the further steps of the process. So yeah, so let's have another pool to get to know you also a little bit better. So what are we're talking about this this analysis step where actually we get to know what's the pain points we need to solve. So this is the question about this. So what will be your biggest pain today in the inspection process? Capturing the data and managing large missions, ensuring training consistency for drone pilots, sorting millions of images, accessing inspection data from different repositories, ensuring defect detection, exhaustivity, aggregating information in specific business dashboards, or building custom inspection reports. So yeah, so maybe, so I don't know, Teresa, maybe
Yes, this is
our invitees have answered, or?
Yeah, I will close the poll. Just a couple of last answers.
Yeah, let's wait a little bit.
And I will close it.
Yeah, perfect. Thanks, Teresa. See if you can display the results. Thanks. So yeah, so one of the main pain point identified by yourselves is capturing data and managing large missions. Okay, so yeah, so maybe we will focus on this part, which is Sterblue software includes trajectory planning for drones. So drones can fly automatically and make sure that all the infrastructure is covered. So the second will be accessing inspection data from different repositories. So yeah, so for this point, managing the data is fully transparent with Sterblue. All you have to do is to drag and drop all the information in the platform, and everything gets sorted by itself. And building custom inspection reports, which is also automatic on the Sterblue platform, as Nicola will show. So yeah, so we will. So we actually arrived to the demo part. So there are two business cases that will be demonstrated by Nicholas. So the first one is was with a major Australian TSO. So the goal here was to assess the corrosion following specific corrosion management policy of this company. So the end of the process was to calculate the number, for instance, of corroded bolts or the surface of the asset which was corroded according to 4 levels of corrosion, and produce an inspection file which was uploaded to SAP, as Nicola will show in a few minutes. The second case we will be talking about is with a large asset owner in the US. And here, actually, we had to aggregate several types of data, which is infrared and RGB pictures, to provide a full visibility of asset integrity. So we have collected here more than 10,000 pictures, which all has been sorted automatically on the Sterblue platform and can be consulted by our clients. So, Nicolas, I'll let you take over here, if you're ready.
Yes, thank you.
Yeah.
All right. I hope you can see my screen. So
Yes.
Welcome to the Sterblue platform. So this is the landing page. This is where everything starts. On this page, we simply summarizes what your account has. So how many structures have been inspected, how many anomalies were detected, images, etc. As Samir mentioned, we're going to take the example of one of our customers in Australia, and we'll walk you through the process of inspection using this data. Well, first we have a map on the Sterblue platform, which allows you to easily visualize all your assets and all the inspection data. So we'll travel quickly to Australia and have a zoom in on the transmission line. So this customer, we're quite lucky because he has some LiDAR data. Not all our customers have this data, but if you have LiDAR data, then everything is possible. Okay, we can extract out of it a lot of things, and more interestingly, your assets, dimensions, and the vegetation which is around your asset. So it's a 3D map where we are able to overlay on top of the satellite imagery, the terrain, and the different towers that are symbolized through this blue boxes. In case you're not having LiDAR data, you could have at least the shape of the tower through CSV files. Okay, you know their height, you know their width, and that's also one possibility we can work also out of this. So our task for this customer was to inspect all of these towers and to deliver corrosion reports for every towers. So what we did is first we automated the flight around the tower. So here, for instance, we represent. So I'll zoom in so that you see it well. But what you see, we can see a trajectory around the red boxes, which are the inspected towers, and it represents the path that the drone will follow in order to inspect this tower. So this is a detailed inspection. So you can see that there are six paths around the tower, which allows to have like the full coverage of the tower to be sure that we are not missing any images. So the drone will automatically fly along this path, and the pilot is only here to ensure that the flight is safe, or to change the battery in case the drone is running low on battery. And we're able also of performing multi-tower flights. This depends on the regulation of every country, but in Australia, we are able to fly up to 700 meters away. So we were capable of inspecting 3 towers from every point. So from this tower, we could inspect the next one and the previous one. Once this is done, I'll show you in video what it looks like. So here we have a small video to demonstrate the flight. I hope the quality will be good enough, but it at least allows you to understand what's the path looking like. So it's of course accelerated, but you can see that the quality I think is very poor because even on my side it's not great. But you can see that the drone flies next to every tower, goes up and down, and takes a lot of images, so 1 image every 2 seconds. And this ensures that we have all the data needed then to perform the analysis. So let's imagine that the capture is finished, and now we want to review the inspection data. We're coming back to the platform. At the end of the day, what the pilots can do, yes, okay, here, sorry, wrong page. What the pilot can do is that they can simply drag and drop all their images on the interface. So that means they take the SD card out of the drone and they drop the images. And then the platform will automatically link every images with a given tower. Okay, so you don't have to manually sort and say, okay, from 10:30 to 11, I was on tower number 1, etc. You can just drop everything, and the platform will make sure they are linked to the correct tower. Then you can see also on the platform all the inspection mission you have performed, and then you can access for a given inspection all the data. So for instance, here we summarizes the data of a given inspection. So on this one, for instance, close to 200 pictures were captured, and you can also have an overview of what was detected by the AI or the experts or both, depending on the customer. We have some customers working using AI or someone using only experts. Let's have a look then at one of the towers that I've showed you on the map just before. So for this tower, you see that we have captured many images, close to 600. And for those 600 images, 65 detections and anomalies were made. And we can see the process through which one inspection is going at the top. So it starts with the upload of the pictures, and then the experts start their work by selecting images, reviewing the images, and at the end, you have access to a report. So I will walk you through some of those steps. So one of the most important is, of course, to have a look at the different images which have been captured. So here you can see that the drone took some images, many images, in fact, from around the tower, which gives a lot of information from different point of view. So if we see a defect on an image, we can also check on the second image if it's also there from a different angle. And this allows to have like a very clear insight on what are the actual defects. So it helps the AI and it helps the experts to determine with precision the severity of a defect or the type of the defect. So if we look at the labeling interface, so clicking on a picture brings us to a page like this. Here we see that the experts have detected 2 corrosion which were severe enough to be labeled. This customer was very focused on corrosion, so every corrosion from low corroded to very severe were labeled, and the customer expected some statistics on the level of corrosions over his tower. So yeah, so the camera take pictures from quite close up, which allows them to zoom in and to have also like some clear insights on the different part of the tower. So, and we can navigate through the different images and review and label the different detections. So some labeling tools allow anyone to easily add or remove defects. We can have also like some filters which allows you to only display some kinds of defects, because I'll show you just after some images that have a lot, it's pretty useful. Well, about images having a lot of defects, I wanted to show you this one because it's also a new way to capture data, which is made possible thanks to a new hardware available on the market. So you know that Sterblue is a software company, and we work with off-the-shelf drones. That means each time there's a new drone, there's also new possibilities for inspection. In this case, we are using the latest DJI drones, the Matrix 300, which has a camera with a big zoom. And this allows us to build one picture out of 20 pictures. So so we capture 20 pictures. Each picture is 20 megapixel, and we built a 400 megapixel picture. And then this is pretty useful because it gives you the complete context, and still you're able to precisely zoom anywhere on the picture and have very good information. So this tower is completely corroded, so it's difficult to see basically where could be like the most severe defect, but at least it's very useful to be able to easily navigate on the tower and to zoom anywhere. Before, at least for our Australian customer, this hardware was not available, so that's why the drone was capturing 600 images for a tower. Now this number of images will be reduced drastically, and this will also make the processing and the visualization of the data much easier. Let's continue with our Australian customer. So once the images were captured, you're also able to locate those images on the platform. Okay, so you remember I showed you the LiDAR data. Well, once the flights are finished, you're also able to zoom on. Well, from the labeling interface, you're also able to have like a map, access to a map view, and so you can also see from where this picture was taken. So you have also the complete context. There's a really strong links between the 2D and the 3D, which allows them to deploy maintenance team more easily because you know basically where you need to address the problems. So same, okay, this is just another view, 3D, which shows you not only one image, but all the images which are captured around the tower. Yeah. So similarly, okay, you can then select one more precisely and switch between the labeling interface or the 3D view. Yes. Moving on with the reports. So more interestingly, probably one of the deliverables you want is a synthesis of what was found. You don't want to look at 600 images, or at least not everyone wants to look at 600 images. So you want to quickly know, okay, where do I need to perform some maintenance? So we have different deliverables on the platform. The most popular one, I should say, is of course PDF reports that you can print and share internally, which summarizes the different defects, comments that your experts would have left on a given defect. So they are interactive. So here, for instance, no, the experts didn't leave any comments, but you could click and then navigate on the interface to this report. Of course, we know that sometimes it's always good to have access to an Excel file, so you can have access to some CSV that has some rich content which when they are online, but you can also like export them to many formats. So I mentioned Excel, there's PDF, CSV. You can also export HTML file. So many formats are available. In the end, for this customer, what was relevant was, as I mentioned, some statistics. The percentage of corrosion for every tower. So on the x-axis, you can see the different towers, and on the y-axis, the percentage of corrosion. So here you can have like the big picture. Okay, I'm not interested in a single tower. I want to know for a complete line, and then you can see some trends going on, etc. So that's also some of the analytics we are delivering. I'll quickly show you a second demo for a customer where basically in terms of input data, it was almost the opposite. The customer had only a KML file. Okay, so we only have the access, we only know where is the line, but we don't know where are the towers. So we can also work with this data. So this is what the customer delivered. Okay, he simply sent a KML file and asked us to perform some detailed inspection. And what we do in this case is we send pilots over there, they capture images, and thanks to the images, then we're able to relocate on the map where are the towers and deliver also this information to the customer. He is then able to update his GIS system with precise location for each of his towers. So because those towers were quite small, looking almost like distribution poles, the process of inspection is much easier than what for the lattice tower I just showed you. We have a process, our pilots are trained to capture 6 images, which allows to have like the good compromise between a number of images and a very high coverage of the assets. So these are the images captured, 2 from quite far away to see the complete tower, and 4 specifically focusing on the conductors and the attachments. So for this mission, so many images, same, were captured. Interestingly, we perform infrared images on top of RGB images. Both are doable, and this allows to have like a different type of defects being detected, more specifically hotspots. So yeah, many images that have been then labeled by DEI and experts. And similarly, we have some powerful CSV file. You can down-filter them to only display the critical ones, etc., etc. So here we see that we have only 3 towers, for which there is some critical defects, and some other views. We're also introducing charts. So this is we're about to release this into production. So which gives you the same for a given line, the big picture. So here we see that the defect, which was identified majoritarily, is hotspots, many hotspots detected thanks to the infrared images. Same, we could filter by types, we could filter by severity. And we also have like some pivot tables, which allows to quickly see for a given tower. So what you see here are the different towers on the line, and then the different defects, the lines are the different types of defects which have been detected. And same, we can say, okay, I'm only interested to detect the most severe one, and this allows you then to see, okay, I see that there are 2 towers, in fact, only, which have major defects. Okay, 201, 203. And then you can quickly navigate here and say, okay, show me what is tower 201 looking like. And then we have a tower 201, which is here. You can make it bigger, etc., etc. So yes, this is it for the demonstration. So we'll be happy to have your questions. You can ask them through the chat. Don't hesitate also to send us an email in case you have a different use cases that we have not covered. We'll be happy to answer back. Thank you.
Thank you, Nicolas. So yeah, about the Q&A, so we add in the chat a question about telecom towers. So indeed, this is a use case that seems pretty close to what we are doing, but we are not addressing it commercially as of today. Then in the Q&A section, we have one question. So many grid operators have to maintain and monitor sensitive components such as polymer insulator and line surge arresters that are used to address pollution and lighting performance. The manufacturer are struggling to develop monitoring devices to assess the condition of this component. Is Sterblue supporting grid operator in that direction? Yeah, I mean, definitely from my side, I mean, I think Nicolas can confirm. This is typically the thing we do, including with AI. So we have AI to artificial intelligence that is able to detect which kind of equipment and do the inventory to say exactly which kind of equipment you have in which quantity on your line and where, but as well to detect conditions on them. So be able to say, yeah, if they have anomalies on them, such as pollution or lightning arrestor have been burnt by lightning or such things. I don't know, Nico, maybe you can confirm, but this is typical. Mm-hmm.
Yes, and it's something I did not emphasize in my presentation, but each defect belongs to a referential, which is can be unique for every customer. So if you have some specific defect, the interface has this flexibility to display it to you, and we can also train the AI on your specific defects. So some are very common. If you want to detect a cracked pole, every utility company has this one. But if you have some specific equipment or specific defect, this can also be put on the platform.
Mm-hmm. Okay, so no other question in the Q&A section for now. A new one, okay, in the chat. Okay, so what about the impact of light condition? Does AI correct photos automatically? So yeah, indeed, there is basically an envelope of acceptable lighting condition. Obviously, if you inspect by night in optical imagery, it's not going to work. But in general, it's really wide like any daytime image work. And yes, the AI is able to adapt to those lighting conditions. Actually, it's trained on a very wide range of lighting condition, and then we apply it on a narrower range. So basically, it's trained on very weird images, and then we run it on more normal images, which means that it's able to correct for those. So that includes images from various sources. As we say, we can mix images taken from the ground, images taken from drones, or from helicopters, typically for transmission lines. And it works. As I said, we also address images from satellite imagery, but that's for different kind of defects, more related to vegetation. Another question in the Q&A section, is Sterblue software completely independent or built on third-party APIs? So yeah, that's a good one. That's, I think, the specificity of Sterblue as compared to some other player in that field is that we are completely independent. All our technology is based on what we built or based on some open source libraries. So for example, for artificial intelligence, we use some open source tools that are provided by Facebook and Google researchers, and then we apply them. I would say the only thing for now is for vegetation analysis. From satellite imagery, we rely on three separate operators to inspect those as of today. Anything to add, Nico or Samir?
No, you said it well.
Okay.
Yeah, maybe I can add just on the previous question. So obviously, so AI can adapt to several conditions and quality of pictures. But obviously, when we deliver the inspections full scope by ourselves and we send our pilots, we have actually a training process, which is based on online training. So it's a training model called Sterblue Academy, and practice with our assistants, where actually we teach our pilots or clients' pilots some best practices to have the best pictures possible. Because obviously, even if AI can see some pictures, it's always better to have the pictures with the right exposure and taking from the right angles. So maybe to emphasize on this, for example, for distribution grids, we take 6 pictures by pole using a smaller drone. And actually, it's from a specific angles, and it's enough to see anything that needs to be seen by the specific clients. And as you've seen on the demo for transmission towers, these towers being much higher and much larger, and the objectives of the inspection being different, we have actually another trajectory, which is optimized to have the best quality pictures possible. But sometimes we have to cope with less good quality pictures because as we mentioned all along this presentation, we manage also pictures not collected by ourselves. So you collected by some partners using helicopters or any other source.
Okay. Another question, can you share this demo with us? So Nico, maybe you can tell more about that.
Yes, and this will you share. I think it's Teresa who will confirm, but yeah, we usually make the demo public, so you'll find it on the website in the following days.
Yeah, but I don't know if you're talking about the demo video or the demo on the platform,
okay.
the data.
The demo on the platform. So if you want to have an account on the platform and play with the tool, yes, send us an email and we can create you a demo account so that you can interact with the platform yourself.
Including some example data, yeah. Okay, it was about the demo video. So yeah, this we can forward it. Yeah, you can have both, definitely. Okay, no other questions. So we are reaching close to the 1 hour limit. So yeah, anyway, let us know if you have any other question. Let's get in touch. We are more than happy to provide you with demonstration and demo accounts. So feel free to contact us. Thank you very much to everyone, all attendees and panelists. Thank you, Teresa, for organizing this, and to all of you for following. And see you soon. Thank you very much.
Thank you.
Bye-bye.
Thanks, goodbye.
Bye.